Hello to everyone. Thank you for being here. Thank you for your presence. Now let me introduce myself. I'm Vlado. I'm software engineer in Microtica, and currently I'm working on AI features in the platform. So first of all, let me share a few words about who we are. I mean, what is Microtica and how we introduce the AI in our platform. So Microtica is sorry, I didn't mention that today I was speaking about building intelligent AI solutions built with AWS Bedrock. I mean, more precise, a deep dive into RAC. So, a little introduction about Microtica. Microtica is a unified DevOps automation platform, which is designed to simplify the way we build infrastructure and deploy the applications on the cloud, where we offering ready-made templates, but also on the top of that we have the cost optimization, we have the monitoring, we have also the alarming as a feature, and many more. So we faced with the AI. We know what is how AI is transforming the world and what is the point of the AI, and that enhanced us to introduce, I mean, to integrate the AI in our platform in order to give our users more benefits, to be more productive and to be efficient. So after brainstorming and thinking where and how to implement the AI, to integrate the AI in our platform, we was thinking, brainstorming what would be the most beneficial for our users, and the most important thing is what data do we have in order to support that. So after analyzing all the options, we enhanced we identified three features, and that features are cloud formation, error handler. The second one is documentation chatbot based on our documentation, and also we have the infrastructure builder. So how we started? I mean, when we identified which features we will build, the next thing that we need to conclude was with which approach to start integrating that features in our platform. So in the beginning we excluded two options, like prompt engineering, because we know that we cannot achieve what we meant to do with the prompt engineering, but later we are using that in order to improve our AI. And also we excluded the training our foundation model from scratch, because we know that it was costly, it was time consuming, but also it was beyond our expertise when we started integrating the AI in our platform. So firstly we started with the fine-tuning. More precise, we were fine-tuning ChatGPT model. We prepared some training data and fine-tuned the model with that training data. And in the beginning, we had positive results because everything that worked. But when we added more and more data, the model started to become biased and to hallucinate it. So we in that moment it was clear for us that also the fine-tuning isn't the right approach for integrating the AI in our platform. So we left only the retrieval augmented generation. So what is retrieval augmented generation? It's an approach that extends already powerful capabilities of the large language models. Means retrieving relevant data from the external data source, and that retrieved data is ingested to the initial user query, and that proceeded as input to the foundation model, and then the foundation model is generating a response based on that augmented prompt. But let's deep dive into RAC. I will explain how the technical stuff is working, and also explain you some examples, the use case. So, in RAC, everything starts with the data. So, the data, the company data, the data is the most important part when doing the RAC, when working with the RAC approach. So the data can be in any format. It can be a CSV file, PDF, documentation, HTML, Markdown, everything. So when we have the data, we need to split that data in different segments called chunks. So when we have the data, we proceed through a process called chunking. Chunking is important, in my opinion, very important part of the RAC approach, because with chunking we are capturing the semantic, but also the relationship between the words. So there is a few types of chunking, like semantic chunking, fixed size of chunks, also the recursive, and many more. But also no chunking is type of chunking. After we prepare the chunks, then the next process is to proceed that chunks to the embedding model in order to embed. So what is embedding? Embedding is numerical representation of the text. So all the text, all the chunks of text are now translated to vectors, and that vectors are saved in vector database, vector store. The vector database is purpose-built database. It's a database, but it's optimized for indexing and also retrieving that embeddings when doing the search. There is a few things that are important to configure when doing the embedding and the vector database. That's the vector dimensions, but also the metric. So the vector dimensions affects to the accuracy, cost, but also to the latency, because if you have higher dimension, then that means that it will require more time to compare all that embeddings when doing the search, and also will rise the cost for saving that data in the database. So this is the first part when we do the data ingestion. So the second part is retrieval augmented generation. So in this part, everything starts with the user query. So when the user is asking some question, that question is proceed to the same embedding model that we use when we are embedding the data and storing to database, and that question is also translated into vector. Then that vector is used to do the vector search in the same database that we created while injecting the data. Then we retrieve the relevant data based on vector similarity search. When we get that data from the database, we ingest that with a query, and then we proceed all that context to the AI model, and that is the retrieval part. And then we have, and then the AI model is generating response based on that augmented prompt, and that is the G part of the RAG. So now let me show you something in action. I will show you how we use this approach in order to implement our features in Microtica. First of all, before that, I would like to explain that all this RAG also has challenges like everything. So like managing multiple data sources, like incremental update to the database, but also the embedding and the chunking, and everything that is that complexity is abstracted by AWS Bedrock knowledge base. So on knowledge base part of the Bedrock, there you can set up a data source like S3. They support multiple data formats, as I mentioned before, like CSV, like PDF, etc. They had a few options for chunking. Also, there is option with Lambda where you can integrate your own chunking strategy. For embedding models, I only listed Amazon Titan, which we are using, but there is few like multilingual for Cohere, etc. And as a vector database, there are a few options like Postgres, Pinecone, OpenSearch, and Redis. Now let me explain you about our use cases. So first, we introduce the AI in our use case, CloudFormation error handler. So for this feature, we have as a data source CSV files. For chunking, no chunking, but I will explain you how we reach there. And for the embedding model, we are using Amazon Titan 2 because it's very good for text searching through and embedding for text similarity. And for that database, we are using Pinecone. We are using also the cosine similarity. There is two options. The first one is cosine similarity and Euclidean distance. So cosine similarity is used when you have spare data, and for use cases like text similarity, recommendation systems, etc. And the Euclidean distance is maintaining distance between 2 points, and it's used when you have dense data, and for use cases like image detection, anomaly detection as well, and clustering some algorithms. So let's now explain about our CloudFormation. I will show you on the console how it's implemented. Also, everything that I show on the console is already implemented in our portal in microtica.com. So I will just explain on the console in order to see all that different and how we get different responses when we have just base model, but also when we have a base model that is extended with the RAG approach. So now, let me also explain how we decided to go with a no chunking strategy for chunking. In the beginning, we maintain a database where we store all the logs that happen in our platform while executing pipelines. So we extracted the data from the database and created some initial CSV file. Then, because also we know the solutions for that errors that happen, and we supplement that initial CSV file with our solutions. And then we uploaded that on S3, and for chunking we started with fixed size of chunking with 200 tokens, as I remember, and that proceed and with that approach we get some chunks that was split without having some meaning. And because of that, because some of the errors that we had in our database were small, some of them were large, and because of that, we didn't have the right approach for chunking. And then we decided to pre-process that CSV file, and for every record that we had on that CSV table, to create a separate file where we do the not do the chunking, but pre-process and create for every record separate file, and there was no needed for further chunking because everything that was chunked before. So except that, we also added a corresponding metadata JSON file which we used in future for filtering, for scoring, etc., etc. Yeah. So now let me show you. For example, this is Microtica, and
can you please increase this font size? It's very small. Yeah, that's good.
Okay. So this is Microtica. As I mentioned, we have pipelines there, and for example, this is some pipeline that it's failed, and we have some error message that happened. It says that stack is in rollback complete and cannot be currently updated. So if I just get this error and put it on some model that doesn't have a knowledge base and hit run, I will get some general response from that model that says some. Let's just finish, which says that you need to delete the existing or investigate the cause of the failure, fix the issue, create new stack, and then verify the new stack. But for example, this is the knowledge base that we created with our errors, and we are using the same model for generating response. And when I try with the when I search the model with the same error, but now this model is supported by external data source, and that is the data that we created. And as you see that here, you can see also which chunks are used in order to generate the response, And if you see that in the response, we have also some steps that says that you need to attempt to redeploy that from scratch using Microtica. So this response has more context because it's using our knowledge base, and in our knowledge base we had a record for the errors like this one that happened on the platform. Here we can see which chunks are used, and also we have the metadata. As you can see here, we have also of the source of the issue, and that's it for this use case. Now let's proceed to the next use case, and that is documentation chatbot. So when generating this use case, we know that how much is important to the users when searching something to be searched very fast and very easy from the documentation. So except that, we also created this use case because also when creating the knowledge base, we needed that knowledge base when creating also response related with the first use case. Because, for example, if in our solution that we provided in the database contains some steps that are related to the Microtica and also to explain in the documentation, when generating the response, we'll be using the both knowledge bases, the one with the errors, but also with the documentation in order to provide to our users solution which is with steps that should be done on our platform. For this use case, first we started with data source web crawler. We used the Bedrock web crawler as a data source. We just inputted our URL of our documentation and used semantic searching, semantic strategy, where we put there sentence group of 1 and breakpoint for text similarity of 90%. And do the chunking, we are using the SAMP embedding model and using the same vector database, Pinecone with cosine metric. But in this case, we used 1024 dimensions because it was more important for us when doing the text similarity search to have higher dimension to do the comparison when retrieving the data. So We started with web crawler as a data source, but unfortunately that didn't work because the chunks there, some of the previous speakers mentioned that can be a scenario where the data that was crawled, that was stored in the database, it had too much noises. It had some JavaScript files, some other things that create the noise, and that produce some responses that didn't have meaning or were incomplete. So we decided to go with another approach, and that was just to download that documentation in Markdown, then reduce that noise, remove the JavaScript files and everything, and also separate separate by heading. So every heading was a different file. Also, we created some corresponding metadata JSON, which also helped us when doing some filtering when using agents, and and we use the same semantic chunking with the second approach, and that on the second attempt we get very good results. So I will like also to show you about that. Let me just clear here. Now I will navigate to the knowledge base that we created for documentation. It's this version. So if I ask Cloud how to create project on Microtica, I will get also some response that is more general. But for example, if I ask here to the same foundation model, Claude, but now we are using our data source, and you will see that this response has more meaning, because if I navigate now to Microtica, you will see it says navigate to the See All Projects button in the header, then click on Create Project, choose a pricing plan. If you compare to this response, you will see that there is nothing explained in that details, and you will see that currently I'm on Microtica. You can see the See All Projects button, also Create Project button, and then you are choosing the pricing model. So the response generated by the model, which is extended with the external data source, I mean our documentation, it has answer that has more context. Now I will proceed to the last use case, AI Infrastructure Builder. So for this use case, we are using CSV as a data source. We are using for chunking, we are no chunking. I mean, we are preparing all that. We are preparing all of the templates before, so no chunking is needed. And for embedding model, we are using Titan version 2, and for the database, we are using Pinecone with cosine similarity and with 512 vector dimension. So for this use case, our idea was to create infrastructure based on the user needs. So if some user comes on our platform and says, I want to create some Node.js application to have database and also some let's say some other database, like two type of database, one for user management, another for storing some objects or some documents or what else. The idea was Microtica to summarize everything that and to create infrastructure on Microtica and deploy it. So for this use case, we also created a CSV data source, but we use our expertise because we have created a lot of cloud formations to let's say for our ready-made templates, and we created some CSV file with a few columns. The first one was requirements, which we explain user requirement. The second was service, which service is created on AWS, and for third column we we created a template URL where we keep the URL of the CloudFormation template. So for this use case is still on beta. We are rolling in production very soon. So I invite you all of you to visit Microtica to share the feedback so we can improve our platform and make it better.